Hello guys, I hope everyone is fine. In today's video, we will be discussing about next concept of dynamic programming, which is longest common subsequence. The problem is that we are given two strings. So in two strings, what we have, one is let's say ABC, and let's say one string is AB. This is string number one, and the string number two is ABCD. Now, in this particular context, what we have to do is we have to find out the longest common subsequence among it. Let's just take the first string as uh, B and D. Now, if I want to basically check the presence of BD in ABCD, yes, it is definitely present, but not together. It may appear in the text, but it's not coming together accordingly. So where we have BD, B is coming, and in this same sequence, D is coming. So BD is actually present, and what is the number of characters which are similar? So there are two characters which are similar. So the longest common subsequence is definitely there, which is BD may not be coming together. It may come together also. Let's say if I am talking about another string, string number one as strong, and the string number two is, let's say, longest. So if I have to find out which is the particular string, or what kind of string which is similar in this particular case, so we can say that there is a similarity which is there, which is ST is present, ST is present, but the length is 2, because ST length would be 2. We can try O. O is present, N is present, and G is present. So O and G definitely is present over here. So again, we can say that the longest common subsequence is ONG, which is simple, and it is coming together. So again, there is a possibility the strings may come together or strings may not come together. I'll take another example with string number one is stone, and string number two is LONGEST, stone and longest. Now, if you can see in this particular example, we have O, which is common, N, which is common, O, N is common over here. But there is O and E, which is coming, and there is E, which is coming, but with the presence of G. But as a longest common subsequence, it will be O, N, and E. So it is not coming together, but the same sequence it is appearing. So the answer would be 3. So this problem can be solved by using dynamic programming. So dynamic programming, as we all know, dynamic programming is a concept in which we will basically solve the problem using tables. Firstly, we will have rows and columns. Now, what you will do is you can put the one string in one row and one string in the form of column. It's up to you what kind of string that you want to fit the column with. Obviously, we will form answers from calculating previous answers also. So whatever answers that we have, we will calculate the answers accordingly. So we'll take one example, a very simple example, and I'm just writing the algorithm of LCS. The algorithm of LCS is that if A of I, which is string number one, is equal to B of J, right? So what we have, LCS I comma J, answer would be 1 plus LCS I minus 1 J minus 1. It means the answer of the next one would be the one added with the left diagonal element. It means left diagonal answer, and we are adding 1 to it. right? So this is when there is a similarity between the characters of the string. Else we have LCS I comma j is equal to, the answer would be maximum of LCS, either a left row answer, or or the answer is upper column answer. So this is how your answer will be. This answer is left row. This answer is either upper column. So that's what we have to basically do. Now we have two strings. I'm taking string number 1 as ABCD and string number 2 as BD. So I am creating a particular table in the form of dynamic programming. Since dynamic programming, I did tell you, dynamic programming is a way in which the problem can be solved using tables. So I'm creating a table for the same, right? So I'm definitely taking one string in the form of columns, let's say, and the other string in the form of rows. This is what we have got, right? So this is A, this is A, this is, let's say, B, this is C, and that's D. Sorry for the diagram. And we have got, yeah, so we have got this as A, B, C, and D. This is, we have taken as BD. Now I'm just taking the algorithm. So I'm taking the algorithm in the form of, I'm putting this algorithm over here so that our calculations becomes a bit faster. Yeah, I'm put. Yeah, this I'm placing it. So just a second. Yeah. So this is your algorithm also, which is placed over here. And since I told in the previous lecture, by default, even if we don't have any first row or second row, we always start with zeroth row. So if there is zeroth row over here and we have zeroth column as well, so what we will have, there is no comparison. We are putting all the values zeros. Now, same applies with all the values 0 in the zeroth column of this particular first first row and second row. This is zeroth row. So technically, we are putting the values accordingly. Now, what we have to do is we have to check. We have to compare this B with this A. Are they same? Obviously, A of I is equal to B of J. This is not the case. So else case will be considered. So these zero values, guys, are previously calculated values, although they don't have any significance. But that's what dynamic programming is. You have to calculate next value with the previous calculated values. So we have to compare this B and this A. Again, this is a clearly case of else part. So either what we have to do is maximum of LCS I minus 1 comma j. Now, if this value I have to calculate, this value is, this is technically that would be LCS of 1 comma, this is this, if this is zeroth row, this is first row, this is second row, right? First row and second row. So this is 1 and this value is 1 1. So it means LCS 1 1 I have to calculate, and this answer would be maximum of LCS. This says I minus 1, it means 0, or j value is 1, which we have to calculate, comma LCS of I value is 1, and j value 1 minus 1, 0. So it means I have to check LCS of either this answer or this answer. This is only if there is no match, right? So it means a maximum of 0 comma 0, the answer would be 0, right? Now the concept is I'm calculating LCS of 1 and second column. So here B is compared with B and they have a match. In that case, the answer would be 1 plus, just see, the answer would be 1 plus LCS of I minus 1. It means if I'm calculating 1 or 2, I is 1, 1 minus 1 is 0, and uh, j minus 1, 2 minus 1 would be 1. So it means I will be calculating 1 plus LCS of 0th row first column. It means I am adding 1 to 1 to left diagonal values. 1 to left diagonal value means that this answer we are having. Again, we are comparing B with B with C. So either my left answer or first answer maximum value, the answer would be 1. B is compared with D. Again, they are not same. So either left answer or top answer, whatever is maximum, you put that answer, right? Now D is compared with A. Again, left answer or top answer, maximum is 0. D is compared with B, either top answer or left answer, the answer is 1. D is compared with C, either left answer or top answer, whichever is maximum, we are putting 1. D is compared with D. So again, that answer would be 1 plus left diagonal answer. The answer would be 1 plus 1. The answer is obviously the answer is 2. And guys, now what we have to do is we have to check the relevance of this answer. The relevance of this answer is that this 2 has come, but this has come because of addition of 1 to the left diagonal element. Now this one has come because this one has come because its left element was 1 and upper element was 0. So it was the maximum that we have to put. So this has come because of this. This one has come because we have added 1 to the left diagonal element, and this 0 has come because of this 0 we have taken as such. Now, what you have to do is you have to check left diagonal, wherever left diagonal elements has left diagonal arrows that you have made, just check those. So first left diagonal arrow is this, and this has come at which at particular element D. Now second left diagonal element that has come over here, this has come because of over here we have with B. So we have got B and D over here. First left diagonal element has come on D and the second left diagonal element has come on B. And actually the similarity between ABCD and BD was BD only. So the total answer we have calculated over here as 2, which is the longest common subsequence. This is known as LCS method, and this is an algorithm of this method. I have pasted this PDF in my description box. So if there is any doubt, kindly put it on comment box. Thank you very, very much. Thank you very much.